In this video, we will be discussing about the chemical classification of matter. From my previous video, let's recall what exactly classification based on a criteria means. In the previous video, we discussed about the classification based on its physical properties. This classification purely was based upon its physique. That means you can look at the substance or touch the substance and classify it into its physical forms, that is solids, liquids or gases. But chemical classification gets a bit trickier here. Chemical classification is purely based upon the composition of the substance or matter. So what do I mean by composition? Composition tells us about the makeup of the substance. So basically, chemical classification is based upon two types. The first one is pure substances, and the second one is mixtures. So what exactly are pure substances? For the classification of pure substances, we need to remember two important points. And the first one is they all have fixed compositions. I'll come back to it in a minute. And the second criteria is that these substances cannot be separated using simple physical methods. Now, what do I mean by fixed composition? Fixed composition means that if you take any pure substance, it will always be made up of the same composition. No matter where you pick the substance from, no matter which time in the history or which time in the future you will pick the substance from, you will always get the substance in the same ratio. Some of the examples for fixed composition is carbon dioxide, my favorite example. So in carbon dioxide, you see that to make one molecule of carbon dioxide, we need exactly one molecule of carbon and one atom of carbon and two atoms of oxygen. You can never get carbon dioxide using one atom of carbon and one atom of oxygen, or one atom of carbon, three atoms of oxygen, or in any other combination. You have to put the elements carbon and oxygen in the ratio of 1:2 to get carbon dioxide. So this is one way you can understand pure substances. And the second one is cannot be separated by simple physical methods. What I mean by simple physical methods is it may be something like hand picking, or it can be distillation, it can be filtration, it can be crystallization. So these substances cannot be easily separated. That means you cannot separate carbon and oxygen by just picking it with hand. That wouldn't make sense. Neither can you separate it by crystallization, distillation, etc. Now mixtures are exactly negations of these. That means here there is no fixed composition, and these can be actually separated using simple physical methods. So what is the example for mixture here is, if you take a glass of water and put sand in it. So what do you get here? This is a mixture of water and sand. So is there any fixed composition? If you take 1 liter of water, you can put any amount of sand. Sometimes you can put only a few grams of sand. Sometimes you can put 500 grams of sand, or you can completely fill it to 3/4 of the container. So there is no fixed composition. You can add as many as you want, yet you will get a mixture of water and sand. So even if you add 1 drop of water to 1 kilogram of sand, you'll yet get a mixture of water and sand. There is no fixed composition here. And what do I mean by simple physical methods is you can separate these. So you can actually evaporate the water and get sand. Now another example you can give here is stones and rice. So you can actually separate stones from rice using simple method of hand picking. So mixtures and pure substances are the first level of classification. The pure substances too are actually divided into two other types. First one is elements. So what exactly are elements? Now you can call elements as the atoms that have same number of protons. Now protons are the particles that exist inside the atom, which are actually very hard to remove out of the atom. It requires a lot of energy and usually happens only through nuclear fusion process. We'll come back to that. So just remember that protons are actually atomic particles that form the atom, and these are positively charged. We represent it this way. These are positively charged and are inside the nucleus of an atom. So elements are nothing but the atoms which have same number of protons. So if you take a carbon element, it will have exactly 6 number of protons. If you take one from India and one from, say, England, one carbon atom from England, it does not differ in its number of protons. Or if you take one carbon atom this year and one carbon atom 100 years into the future, it will yet have same number of protons. That's what elements mean, that they have fixed number of protons. And one important way or easy way to understand if something is an element or a compound is, it is represented by a single letter, or sometimes it is also represented at the max by 2 letters like Fe, this is iron, or He, this is helium. And you do not get any subscripts here. You do not get He2 or H2. These are not elements, even though H2 is widely present. O2, oxygen molecule, these are molecules. We'll come back to that later. These are not elements. You do not have the subscript. Any letter without a subscript can be called as element. And one important fact that we need to know about elements is that these cannot be chemically broken down into simpler parts. You know that carbon is an atom and it will have a nucleus and electrons moving around them. Okay, so you cannot make this atom react with something to get protons and electrons and neutrons separately. There is no possible way to react an atom with something to get its nuclear particles or nuclear constituents. So this is one important part of elements. No chemical reaction is possible to divide it further into any simpler parts. Now, after classification of pure substances into elements, we have another important classification of pure substances, and that is compounds. So compounds are actually, in simple words, we can say they are a group of elements. So one example I'll give you here is carbon dioxide, my good friend. So carbon dioxide is made up of 2 elements. As I said, element is nothing but a capital letter or a group of capital and small letter without a subscript. So it will be C and O. These are the elements, which have in fact combined in the ratio of 1:2 to give carbon dioxide. That is 1 carbon and 2 oxygen. So in this, we can see that carbon dioxide is a compound and it is made of a group of elements, that is carbon and oxygen. Now, some of the important properties that we need to remember here is compounds are always formed in fixed ratios, and we know that since compounds come under the classification of pure substances, and pure substances themselves are made up of fixed compositions. So first of all, they are made up of fixed composition. That for carbon dioxide is 1:2. If you take H2O, it is 2:1. That is 2 atoms of hydrogen and 1 atom of oxygen. Another important property of compound is that, let's to understand this property, take the example of water, H2O here. You know that hydrogen is good for combustion and oxygen is also a great supporter of combustion. These two are actually helpful in combustion processes, but when you mix hydrogen and oxygen, the ratio of 2:1, you get water, right? Now what does this water molecule and combustion process make? When you add water to a combustion process, it actually extinguishes the fire. That means hydrogen and oxygen are actually supporters of combustion, but water is not. So what we claim from this is the properties of a compound differ from the properties of the elements by themselves. So this is one of the most important properties that compound possesses. That means it may or may not have the same properties as those of its elements. And another important property is that these elements cannot be separated by using simple physical methods. I already told that in pure substances classification. That means you cannot separate hydrogen and oxygen simply by using hand-picking method or distillation method. Now the second classification that we had seen was that of mixtures. Mixtures are divided into two types, that is homogeneous mixtures and heterogeneous mixtures. Now these are pretty simple to understand. Homogeneous mixture has the same composition throughout. What I mean to say is that if you take a glass of water, add salt to it, and you stir it well. After some time, salt completely dissolves into the water. That means you cannot make difference between salt and water. You cannot say here is salt, here is salt. It is completely mixed and you cannot see it. That is known as a homogeneous mixture. That means there's a single phase. Now phase is a very important word and we'll be coming across this many times. At present, let us say phase is nothing but the number of layers of substances that you can distinguish. Since you cannot distinguish between salt and water here, it has a single phase. Now what is heterogeneous mixture? Let's take an example. Let's take a glass of water and add sand to it. The sand does not dissolve and gets settled at the bottom. So it has a double phase. Now what I mean by phase is layer. You can actually make out the difference between water layer and sand layer. Hence it is a heterogeneous mixture. Heterogeneous mixture need not be compulsorily a double phase. It can be triple or in general a multiple phase mixture. In homogeneous mixtures, the substances that produce the mixture cannot be seen. In heterogeneous mixtures, the constituents of its substances can be easily seen.